In this tutorial, we're going to look at the process of importing a 3D model into your software. We're going to look at how to orient, position and scale the Z height of your model, and then we're going to show you how to create toolpaths, where we'll be looking at the 3D roughing, 3D finishing and the profile toolpath to cut our part out. So let's go to File, Close. So we're going to begin by defining the area that we are going to import our 3D model into. And this needs to be big enough to accommodate the model with some space around it to allow us to cut the part out. So we're going to start by creating a new file. So here we specify the dimensions for our part. So we're working with a single-sided job. The width of this is going to be 10 inches wide. The height is going to be 10 inches. The material thickness that we're working with is going to be 3/4 of an inch. You can see if you wanted to change the units, you can by switching to metric if you wanted. In our case, we're going to use the inches unit. Then we need to set our Z0 position. So we're going to set that off the material surface. You can see that we have a red dot on the graphic that's showing us where typically we'll be setting our Z0, so that's on the material surface. The other option is on the machine bed, and you can see that graphic updates there. In our case, we want to set that to the material surface. And then we need to specify our XY datum position. So here we're going to have that set to the lower left hand corner. We can see the red dot on the graphic that represents our job space here. We can also see that indicated in the 2D view using this red square there. Then we have 3 different modelling resolutions that we can choose from: standard, high and very high. And so the higher the setting, the better quality of the model that we would have, but that would mean that would have to face slower calculation times when we come to create the toolpaths. In this case, we're just going to go with a high setting here. So we're just going to click on that. And then we can specify our material settings. And if we click on that, that will open up our appearance drop-down list. And if we click on that, you'll see various different types of wood, metals, stones, and we've got plastics in there as well. And these just all reflect the appearance that we will see our 3D part in. And so it's really good to choose one that's appropriate to the material that you are going to machine into to give you a really good indication of what your part's going to look like. And so you can look at adding in new textures by using the Add New Texture option, where you just simply add in the bitmap of the material that you'd wish to use. In our case, we're going to go with Canadian Maple, and then we can just click over here to accept that. And then once we're happy with our job setup, we could simply go ahead and press OK. So the first operation that we're going to do is we're going to look at importing in a component. And so to do that, we need to go over into the modeling tab over on the left here. And then we're going to use this icon here to import a component or a 3D model. And that will just open up a dialog where you can then navigate around your PC to search for a model. In the project folder, we're going to use the magnolia flower V3M file. So we're going to click on that, and then we're going to use the open option here, and that's going to import that into our job. Now, when you are working with 3D parts, it's much easier for you to see both the 2D and the 3D view here. And so we can look at tiling our windows so that we can see both the 2D and the 3D view. To do that, we can come up to the View toolbar. We're going to use this icon here where we can tile our windows vertically. And if I click on that, you can see that we have the 2D view on the left-hand side, and then the window in the right-hand side represents our 3D view, where we can actually see the 3D model. And so here we can only see the model that's in our work area. And so only the area of the model that overlaps the white space that you can see here in the 2D view will be visible here in the 3D view. So we need to look at moving our 2D grayscale or our 3D part into the center of our job so that we can see the entire model in our 3D view. So to do that, we can come over to our Drawing tab, and we're going to go into the Align Selected Objects tool. And if we click on that, that's going to open up all of the options for us to align our parts within our space. And so here we can align this both vertically and horizontally to the center of our job. And if we click on that, we can see that it's moved that to the center there, and now we're able to see the full model in its entirety. So let's just close out of the alignment tools. Now we're going to look at ways in which we can transform our object. So at the moment the object is currently selected, and if I select it again, you'll notice that we have access to these handles, and these are our transformation handles, and if I pull on any one of these, it's going to transform the size of our part. For example, let's take the top right hand corner, and if I click that with the left mouse key of my mouse and then just drag that up, you'll see that our part gets bigger in this direction. I can do the same also in the 3D view. So we have the same handles available to us here in the 3D view, and I can click on that handle there, and then we can just look at dragging that down, and you'll see again that we've transformed our object and made it much bigger. And so no matter what view I'm transforming the model, I'm able to see the result of the transformations in both the 2D and the 3D view. We also have access to these blue handles in the corners as well, and these are our rotation handles. And so we can click any one of those and we can look at rotating it to the left. And again, in the 3D view, we can take one of those handles, for example this one here, we can rotate that to the right just by clicking and dragging. And so we have access to all of the dynamic manipulations of this like I do when I edit a vector. The only difference here is that I have the option to alter this in both the 2D and the 3D view. Now we could also be very precise about the manipulation as well. So let's just undo all of the steps, and we'll just go and use the undo tool here. So we'll just undo that until we have it in the center of our job. And so with our object selected, to alter the size of this, we can come over to the Transform Objects section of the Drawing tab. We can use the Set Selected Object Size tool. If we click on that, that's going to open up the Set Size tool where we're able to alter the size of our part. So here we're just looking at scaling our selected part, and we're just going to go ahead and set our anchor point to the center of our part. So we're scaling from the center, whereby we can now specify the width and the height. We currently have link XY checked, and what that means is if I alter the value of either the width or the height, then the other value will auto scale in proportion to the value that we changed. So for example, if we say we wanted the width of this to be 11 inches, we could input 11 there, and you'll notice that the height has automatically changed, but the percentage is actually the same here, and that's because we're scaling that in proportion. If I go ahead and press apply, you'll see that it will make those changes there. Now this is actually too big for our job space, so we're actually going to reduce that. So we're going to put in a width here of 9 inches instead. So we'll put in 9 in there. The height has automatically changed there, and we could go ahead and press apply. And by having the auto scale Z checked on whilst we are making these transformations, it's actually scaling the Z height of our part in accordance with the actual width and height of our part as well. So let's just close out here. So let's have a look at how we can precisely rotate our part. So again, with our part still selected, we're going to go into Transform Objects and we're going to look at rotating selected objects. So here we specify our pivot point or the center point of our object, in which case we want that in the center. We can see that indicated by this target here, and you can move that if you wanted to alter that pivot point, in which case we want to rotate our part about this center point here. So we're going to make that a relative move, whereby we're going to specify an angle here. For example, let's make that 5 degrees. And if we press apply, we can see the result of that there in the 2D and the 3D view. So let's just close out here. We can look at mirroring our part if we wanted. We can do that by going into the Mirror Selected Objects tool, whereby we can mirror that as it is, or we could mirror the rotated bounds. In this case, we're just going to mirror our part as we see it here, whereby we can flip that horizontally or we can flip that vertically. So let's just have a look at the effect of that when we flip that horizontally. We can see how that looks there. So I like the way that that looks, so we can simply close out here. Now the 2D orientation is correct, and so the last thing that we need to check before we can start calculating toolpaths on this part is the height of the object in the 3D, or what we refer to as the Z height. So to do that, let's come over into our modelling tab, and then with our component selected, we're going to use this wrench icon here, and that's going to open up the properties for our component. We can see the shape height displayed here as 0.4976. We're going to increase that. We're going to make that 0.55 and press the space bar to accept that, and that will adjust the Z height for us here, and we can see the result of that in the 3D view. So now we could go ahead and close out. Okay, so we now have our model ready to apply our toolpaths to. So we're going to switch over from our design tab over to the toolpaths tab. So we're going to use this icon here. That's going to temporarily draw in our design tab, and it's going to open up the toolpaths tab over on the right hand side. And so the first and the most important thing we need to do is check over our material setup. And so this material setup is how we're going to set up our physical material when we come to set that up on our CNC machine. So we just want to make sure that everything within this form is going to match up with what we're going to do on the CNC. So here we have a thickness of 3/4 of an inch. I'm going to set my XY datum position in the lower left hand corner. I'm going to set the Z0 position off the material surface. So next up we have the model position in the material. So this is where we position our 3D model within our block of material. And it's a good idea to apply a small gap above your model, so if there is any discrepancies in your material flatness or how you set the Z0, you'll make sure that you avoid any flat spots. And so we can move this by using the scroller here, and you can see this lighter colour in the graphic here represents our 3D model in comparison to the material thickness of the part that we're using to machine this out of. And again, we can just use the scroller here, or we could put in precise values either on the gap above or the gap below. In which case we're going to put in a gap above here of 0.05, and you'll see that that graphic has updated according to the gap above value that I've entered into that field there. And so because we've got that gap above of 0.05, we also have a gap below of 0.15. So we know we're going to have extra stock underneath the actual 3D model that we're going to cut out. Moving on down, we have the rapid Z gaps above the material. So we need to set our clearance and plunge settings. So the clearance is basically the height above our job at which it's safe for the cutter to move at rapid or maximum feed rate. And then the plunge is basically a gap that's the tool will rapid down to during plunge moves. And so we're just going to leave these as 0.2 as that seems safe enough for my particular setup. You're going to want to make sure that's also appropriate for your own setup, so ensuring that you're clearing any clamping mechanisms that you have on your job so that the tool doesn't go into those mechanisms. So please check over your own clearance and plunge settings to ensure that they're safe and appropriate for your machine. And you also want to check your home and start position, ensuring that you're starting off safely at X and Y. In my case, I'm going to leave that at 0, 0 with a gap above of 1. And then we could simply go ahead here and then press OK. So now we're ready to calculate 3D toolpaths. And it's important to understand what these 3D toolpaths will machine. Now at the moment, the flower is currently selected, and if I just deselect that by clicking into our space here, it isn't actually relevant to what I'm going to cut. The only thing that is relevant here is if the 3D object is visible in the 3D view. And so what we see here in the 3D view is the result of the components that we have visible within our component tree. And the order that they are in and the combined modes of the components and the levels, and the result of all of that is what we refer to as our composite model. And this is what we see within our 3D view. And in this example, we only have one single object and it's visible in the 3D view, and that's what we're going to cut. And so what we have selected is completely irrelevant here, and the software will always calculate toolpaths based on what is visible here within our 3D view. When machining 3D parts, we make use of two different toolpaths. The first toolpath being the 3D roughen toolpath. This toolpath allows us to use a larger tool to hog away at the majority of the material. And then the second toolpath is the 3D finish toolpath, and that's where we use a much smaller tool to cut away at the finer details that have been left over from the bulk of the 3D roughen cut. And so that's what we're going to look at here. So let's head over to the 3D roughen toolpath. So that's this icon here, and if we click on that, that will open up the roughen machine toolpath form. So the first thing we need to do is select a tool from the tool database. You can use the select option to open that tool database, and here I have my tools according to the material I'm using and my CNC machine that I'm using here. We're going to use the 1/4 inch end mill. I'm just going to check over the settings, ensuring they're safe and appropriate for my particular setup, and then would go ahead and press select. Next, we need to specify a machining limit boundary. So this is where we tell the software where we need to machine. We have the choice of the model boundary, so it will take the model as the bounds for us to machine into. The material boundary would take the entire material. If you had any vectors, you could specify those vectors to machine inside those vectors. And if you're working with various levels, you can specify a level here. In this case, we're going to go with a model boundary, and it's going to take the bounds of our model that we've got in our 3D view. Moving on down, we have the boundary offset. Okay, so you want to set this so it's large enough to allow your tool to come down to the side of the part. And so by default, the software is only going to take the center of the tool to the edge of the boundary, and we want that to go past the edge of the model by at least the radius of the tool plus the machining allowance, just to make sure that the tool will fit down the side of the part. So in this case, we're just going to go with a boundary offset of 1/4 of an inch. Then we move on to the machining allowance. So this is a virtual skin added to the model to keep the rough tool slightly away from the finished surface. That just helps to avoid the larger tool chipping at the finished part. So here we'll just go with a value of 0.03. Next up, we have the roughing strategy, where we have a Z-level strategy or a 3D raster strategy. Now the Z-level strategy will cut our part in 2D slices and it will just leave a stepped finish. The 3D raster strategy is more like a semi-finish and it will just go back and forth over the part with the roughing tool. And we're going to use this option where we're going to ask the software to avoid any machined areas, and this will mean that if an area has already been machined by a previous pass, then the current pass will try not to remachine this area. So then we're going to set our raster angle at 0 degrees, so that's just going to go back and forth along the x-axis, and then we can give that toolpath a name, so we could just leave that as 3D roughing 1, and then we can simply go ahead and press calculate. And so the software will automatically open up the preview toolpaths form where we're able to visualize what our toolpath will look like before we run that on our CNC. So here we have various options for how we view our toolpath. So we're just going to go the material color in our case, and then we can animate the preview and draw the tool. We're just going to undraw both of these options for now. And then we can simply go ahead here and preview that toolpath to take a look at how that would look. And so we can see that magnolia is starting to appear through there. And so using the larger tool, we're hogging away quite a lot of the material. So then we can go in with a smaller tool to really get all of the detail out using the 3D finish toolpath. And what you see here is exactly what you're going to see on your CNC machine. And so if there's something that you didn't like at this stage, you can edit that until you are happy with the preview to then safely go on to take those toolpaths over to your CNC machine to cut your finished part out. So we'll just put that back in C. We're going to close out now. And now we could look at creating the 3D finish toolpath. So we're going to use this icon here. When we click on that, that will open up the Finish Machine in Toolpath form. So the first thing we need to do is select a tool. I can see at the moment I currently have an 1/8 inch ball nose selected, and I'm actually happy to use that. However, I can use the edit option here just to check over the settings for this particular tool, ensuring that everything's safe and appropriate. And if I wanted to edit them, I could edit the settings for this particular tool for this particular toolpath without it affecting the data that we've got stored from the tool database. So I'm actually happy with all the settings that we have here. We could go ahead and press OK. Next up, we need to specify the machining limit boundary. So this is exactly the same as what we was working with in the 3D roughing toolpath, in which case we're going to use the model boundary here. Boundary offset, so we're just going to let the tool roll past ever so slightly. We're going to do that by 0.1 of an inch. Then moving on down, we have the strategy for our 1/8 inch ball nose, where we can select to have that as an offset strategy, where it will just go round and round and round, or we could specify to have that as a raster strategy, where it will go back and forth as the graphic shows you here. And so we're going to set the raster angle at 0, so it's parallel to the x-axis, and then we can give that toolpath a name. So we'll just go with the default here, 3D Finish 1, and then we could go ahead and press calculate. Okay, and we can see that the software has again automatically opened up the preview toolpaths form. We can see the toolpath has been added to our toolpath list. We can see the visibility of that toolpath here within our 3D view. And you can see that we are displayed with a blue flower here, and that just shows how dense our toolpath is this time, where it's much finer, it's much closer together, it's much tighter. And then we can simply go ahead and we can actually preview that toolpath to take a look at how that would look. So let's just maximize the 3D view. We can really take a look at our part. So you can see that our 1/8 inch tool has managed to pick up all of the detail that we have for our magnolia flower. And I really like the way that this part looks. So now we need to think about how we cut our flower out of our material block. So let's just go and tile our windows. We'll put that in C. We'll just close out of the preview toolpaths form. So we need a vector boundary that represents the boundary of our model. So to do that, we're just going to switch back over to our design tab. And within the modeling tab, if we select our component, we can make use of this option here to create a vector boundary around the selected components. And if I click on that, you'll see that that's created a vector there that represents the boundary of the component that we had selected. We can use this vector in order for us to run a profile toolpath with to cut our magnolia out of our material block. So let's just switch over to the Toolpaths tab, and with that vector selected, we're going to go into the 2D profile toolpath, and if we click on that, that's going to open up the 2D profile toolpath form. So we're going to set our start depth of 0, and the cut depth is where we tell the software how far down we want to cut into our material, in which case we want to cut all the way through our material. So we're going to input Z followed by the equals key, where the software will auto fill that field based on the thickness of the material that we've set for this job. And so we can see it now reads as 3/4 of an inch. We specify our tool, in which case we're going to use a 1/4 inch tool, and if we use the edit option, we can just glance over the settings here, ensuring that they're safe and appropriate for our particular toolpath, in which case I'm just going to look at increasing the pass depth here. So I'm going to increase that to 1/4 of an inch, and we'll OK that. And because I've edited the tool from the edit menu, it hasn't actually affected the settings for our 1/4 inch end mill from within our tool database, and it's only applied it to this particular toolpath. So we're going to machine that on the outside of our vector that we've got selected here. And then we can simply give that a name. So we'll call that one profile, and we can go ahead and calculate that. We can see that the software has opened up the toolpath preview, and we can see the toolpath visible here in the 3D view, along with the wireframe drawing in the 2D view as well. So let's go ahead and we'll just preview that toolpath. And then if we wanted to, we could delete away the waste material by double clicking on that there. And then we can take a look at our part, and this is exactly what we'd expect to see when we come to run this on our machine. And so it's very important that your part looks correct at this stage, as the toolpath preview shows you an accurate representation of what we would see on our CNC machine if we was to go ahead and run these toolpaths. So if something doesn't look as you wanted it here at this stage, then you can go back and make edits to the toolpaths and recalculate them until you are satisfied with the results that you can see here in the toolpath preview. And that's what makes this toolpath preview such a powerful tool. If you wanted to, you could look at saving out a preview image of the preview here, and that way you can then go ahead and send that to a customer for approval, and then if I get the approval from the customer, I can then go ahead, rest assured that I've had that confirmation, in which case I can then go ahead and save out those toolpaths to run that on my CNC. And so to do that, you simply use the Save Preview Image option, in which case we can just call this one Flower, and then we can simply save that out, and then we can access that from the folder and send that to our customer. So let's just close out of the toolpath preview. So now we could look at taking our toolpaths and saving them out in a language that our CNC machine understands. So to save toolpaths, go into the Save Toolpath icon over here. Okay, so we want to save out all of our toolpaths. Now we do know that we are using a 1/4 inch tool for the roughing toolpath, an 1/8 inch ball nose for the 3D finish toolpath, and a 1/4 inch tool for the profile toolpath. And so what we could do is we could look at saving all of our toolpaths to multiple files. So if we use this option here to check the visibility of all of the toolpaths in our list, we could use this option here to output all our toolpaths to multiple files. So we'd have a toolpath file for each one of these toolpaths. And if you wanted to, you could group toolpaths where possible, whereby we can group them using the same tool. So in theory, we could group the 3D roughing and the profile toolpath as one toolpath because they use the same tool. Now in this case, I'd like to actually machine our parts in this order, so I'm not going to use that option here. And so with all of our toolpaths listed here in the Toolpaths to be saved section, we can then go ahead and save the toolpath. So for demonstration purposes, we're going to save that to our desktop machine that uses the post-processor G-code arcs inches. And you'll need to ensure that your machine and the post-processors for that machine are used here. You can learn more about machine configuration and saving toolpaths in the related videos section for this tutorial. So in this case, it would just go ahead and would save those toolpaths out. And here you can see that the file name is just taken from the first toolpath in our list. So we can change that, and we're going to call this one flower. And then we can simply go ahead and then just press save. And so if we open up that folder, we can see the toolpaths that we saved here. So we've got flower 1, 3D roughing, flower 2, 3D finish, flower 3, profile 1. And we can take each one of these files over to my CNC machine, where I can then run these on the machine to cut the flower model out. So let's just close out of here, and then we'll just close out of the Save Toolpaths form. We'll just undraw the visibility of all of our toolpaths there. So that concludes this tutorial. So let's go ahead and save the file so that we have access to it, where we could make edits to the part at a later date. So we'll go to File, Save As, and then we're going to call this one Importing the Flower Model, Getting Started. Save it out, and you can access that from the project folder.